So with that, I'll take it away. We're going to talk today about cross-disciplinary R&D and how it's advancing plant-based meat. We have 4 distinguished researchers who are taking very different approaches to food R&D, and I'm really excited to have them here. Before we start, I thought I'd just give you one stat as a starting point, which I believe Bruce Friedrichs already mentioned this morning, but it's worth mentioning again. 90% of U.S. consumers eat meat, and 47% support a ban on slaughterhouses. And this is a survey from the Oklahoma State University Agricultural Economics Department. And I can just hear various ag professors I've interviewed over the years grumbling and saying, do people know where their meat comes from? They're just so sentimental about where meat comes from. But at the same time, I think we can look at that stat and say, well, there's a lot of people out there in the U.S. who eat a lot of meat and love meat, but also don't like how some of it's getting produced and are interested in plant-based alternatives that are delicious. And according to Nielsen, we've seen about 24% increase in sales in this plant-based protein category this year. And there was a study last year that suggested, though, that it's still a pretty small number overall. So if we have about $100 billion worth of meat sold by 2021, just about $2 billion of it will be plant-based protein. So that's where we're going to sort of start off with our panel. Is several of them are representatives of large food companies, and there's a lot of money getting invested in this area of companies that see a real opportunity here. So what are these companies doing, and how do they approach this issue of making plant-based protein that actually tastes good and is appealing to eat? So on your right, at the end of the panel, is Monjur Hossen. He's a principal product development scientist for the Kellogg company, and he has access to a ton of market research that Kellogg has done about interest in this area of plant-based meat, and he's going to tell us a bit about the work he's doing at Kellogg to develop new products, and really looking forward to that. To his right is Lav Varshney. He's an assistant professor of electrical and computer engineering at the University of Illinois, Urbana-Champaign, and before he had this job, he was running a project for IBM called Chef Watson, which used artificial intelligence to generate new recipes and new foods. And he's taking this very challenging problem of trying to make computers be creative and apply it to food. So really looking forward to hearing what he has to say about his current research projects. Next on our panel is Scott May. He's the head of a food and beverage incubator called MISTA. They're funded by a large Swiss fragrance and flavor company called Siegel, and he has a whole bunch of projects and ideas that he's going to share with us today. And last but certainly not least is Justin Siegel, an assistant professor of chemistry, biochemistry, and molecular medicine at UC Davis. His work involves the design and discovery of enzymes that are useful for people, and it includes food and sustainable agriculture, but he also studies other areas such as the production of useful chemicals, waste management, and he's going to talk today a bit about how catalysts can promote nutritional availability. So with that, Monjur, can you please take it away?
Sure. First of all, thank you, Good Food Institute, for giving me that opportunity to talk about the plant-based food, which I am strongly passionate about. So before I start, I actually want to take you way back 1991, when I was undergrad student in Kanpur, India, and I was living in dorm, and I believe it was lunchtime when they actually served the dish. It looked like the kind of meat stew. So I was very excited to see that one, because usually you get non-vegetarian dish as a special item that you have to buy those. But the moment so as I said, I was very excited to see that one, and then I took a handful of that, and the moment I put that one in mouth, there was some disappointment. So at that time, I could not figure that one out what it was until I get into the food science. So kind of fast forward, I am very appreciative that the Morningstar Farm brands, we are constantly kind of innovating uncompromisingly delicious food so that that disappointment that I had, it does not happen. So because that was to me is like kind of quite unpleasant experience that I had. So today I would like to basically touch the two key research that we are very excited about. The first one is basically removing the flavors and then the colors from our Morningstar Farm and basically converting them into the natural flavors and then the colors. So that task was not as easy as you might think, because when it comes to the flavor, if we look into the real meat, in the first session we covered that one, there are tremendous amount of chemical reactions happened when we actually cook meat. So just converting some artificial flavors to the natural flavors is quite daunting task, but we're very proud and that we were able to basically convert that one with our extensive knowledge, the food science knowledge that we have, and the culinary skills that our food scientists and then the technologists that we have. And then also we have very strong analytical chemistry group that actually supported us to make that happen, analyzing our product, understanding what happens in the meat in terms of the Maillard reaction. So it's basically all these things together enable us to do that basically. And then the other second aspects of our research was converting some of our portfolios into vegan products. So as you know, not all our Morningstar farms are vegan. Recently, we actually converted some of our products into the vegan. One of them is like meat lovers and then the vegan lovers. Veggie lovers, the vegan the burgers. And then also we converted some of our the chicken products into the vegan. And again, it sounds pretty kind of simple, like why don't we convert everything to the vegan? But as you know that when it comes to like egg white that we use in our the Morningstar Farm products, so it's not easy to find those alternatives and then put it into our products, because we don't want creating a problem by solving another problem. So we want to basically look into from the totality so that what we believe in firmly, we basically follow that and stick to that. So our goal is to basically kind of do more of those products converting to the vegan products.
Okay, thank you.
All right, should I go next?
Yes, please.
All right, I guess Monjur took you back maybe 30 years. Let me take you back 500 years. In my study of history, I find the introduction of the potato to the Old World to be quite incredible. So after Columbus, it came to Europe, and it was around for maybe 100 years, but people didn't really like eating it, even though it was more nutritious than other staple products. But then there was this cookbook that was written by Parmentier, and that's when the potato really took off. And it's very interesting to ask, like, why is it that once you were able to make flavorful recipes out of something, that's what really drove adoption? And now you can't imagine a lot of Asian or European cuisines without potatoes. And we've been thinking about this question quite a bit. So how can we come up with artificial intelligence algorithms that could give us very fast product cycles for coming up with flavorful recipes, flavorful formulations, texture that has good mouthfeel, and so on. And so when I was at IBM for some years, I had started the Chef Watson project, and we had come up with algorithms that could generate novel and flavorful recipes. And since I've been at Illinois, we've been pushing ahead in some of these same directions, but also starting to look at ingredients like algae, trying to ask, can we understand the chemistry and the psychophysics of human flavor perception and actually develop new formulations, new full recipes that will make it quite flavorful. Moreover, we've been developing a lot of machine learning algorithms to understand kind of the factors that contribute to flavor perception. In the earlier panels, there was this kind of large question that was asked: how do you deconstruct the factors that contribute to liking or to sensory results? And so that unmixing problem is a very interesting one in machine learning, and something we've been looking into quite a bit. So trying to put together these ideas of information spreading and behavior change together with artificial intelligence and neural network approaches to style transformation of dishes and flavor science and chemistry, all kind of in some nice ways. So that's what we've been working on, and we're quite excited about these research directions.
Please, Scott.
Cool. So thank you very much. Scott May. I'm the founder and head of MISTA. It's a new platform that's funded by Givaudan, which is the world's largest flavor company out of Switzerland. And if we're throwing age around, it's 250 years old, just in itself. Prior to that, I was leading our global innovation group for Givaudan flavors. And so a couple things I'm really excited about, of course, is the MISTA aspect that we're venturing on. And the MISTA platform is based on three things. One is a physical location, so we'll have essentially an incubator right here in the Bay Area, where we can bring in both startups and also corporate CPG companies to really work on new ideas, new inventions, and actually play with materials to really change the world. The second component of the platform is an ecosystem. So we're putting together an ecosystem of both members and partners to really work together, because alone nobody can change the world, no single company, no single person. So our view is that together we can really create change. The third component of the platform of MISTA is around funding. And of course it takes money to fund some of these companies, these new startups. And so our partners will be bringing funding to bring some of the early stage ideas to market. And so together, these three things in the platform will be optimizing the ideas, the products, the people, and especially in the investments to really change the landscape and the future systems of our food. So that's MISTA. On the Givaudan side, some really exciting areas that we've been working on. Of course, with plant-based protein, we've all talked about how important flavor and taste is. And so some of the research areas we've been focusing on is understanding what's happening in those taste profiles. And so one of the things that happens when you have a plant-based protein is flavor actually gets bound up in the material, and it doesn't release either at all or it releases in a strange way. And so one of the products that we've developed is a blocker that essentially goes in and sacrifices itself into the protein on the binding site, so that when you're adding a flavor to it, whether it's a chicken flavor, a beef flavor, or something, that it actually releases in the right way. So that's some of the research we've been doing. Masking is another big component. How do you mask the cardboard flavor? We have a lot of solutions there that we've been working on. And then, of course, characterizing flavors. And if you're making vegan products, you have to have non-meat chicken, you have to have non-meat beef. So we've done a lot of research in that space as well to provide our customers, like Kellogg, solutions for natural flavors into their products. And then the other area of interest is in the taste. So earlier today we heard a lot about the impacts of taste and the importance of that. And so Givaudan, for the past 15 years, has invested a lot of money in understanding the physiological aspects of how humans taste, whether it's umami, whether it's salt, whether it's sweet, bitter. And by understanding that, we can create solutions on how to address those problems. And even now we're moving into the space of mouthfeel. So when you put a piece of meat in your mouth and you get all these attributes, how do you translate that into a plant-based material and get the same kinds of mouthfeel? So those are the research areas that we're super excited about, and thanks for having me.
Thank you.
Cool. So, as Andrew mentioned, my real focus is developing novel biocatalysts for thinking about how we improve the nutrition of the food we eat and the value of the food we eat. And as far as developing novel biocatalysts and biotechnology, I mean, I really have to emphasize that right now, today, I would argue, live in the most exciting time in the history of the world. Over the last 20 years, the cost of DNA sequencing, so our ability to read in the language of biology, has decreased by 1 billion-fold. Our ability to write DNA, or synthesize DNA, so that's being able to write in the language of biology, has decreased 100-fold and is approaching 1,000-fold. And in the next couple of years, almost certainly will get there. So just in the last 20 years, we've gone from living in a world where we sort of kind of understood where we were. We could see the words and we could live in the culture of nature, but we couldn't communicate with it. We couldn't read the natural world, and we couldn't write in the language of the natural world. And just today, we're able to do that. So imagine becoming fluent in a language that we've never, in the history of humanity, in the natural world, been fluent in before. Very literally, it is unfathomable what we can do with this, and we're just starting to scratch the surface because all of a sudden we have these tools that are disposable on hand. So that's really where we are. We're trying to take advantage of these tools, and a lot of us in the field of synthetic biology are trying to take advantage of these tools and try to think about how to use them. And so for a clean example of trying to use these tools to enhance the nutritional value of food, in India, Africa, and China, there's a massive problem with a contaminant called aflatoxin. Who's heard of aflatoxin? So that's pretty good. And that's only half the audience. A lot of times I talk about this, that was about half, from my perspective, that was about half the audience. The other half, I'm just going to assume, didn't want to raise their hand, right? So it's a class 1 carcinogen, and it's been associated and likely to be shown causal for stunting and anemia. It's found in roughly 0, maybe 1% of the food sources in North America and Europe, and it's found between 80 and 100% of the food sources in Africa, India, and China, well above the legal limits of what's considered safe in US and Europe. So that's a massive issue, particularly if you think of plant-based proteins. Legumes, I think we can all agree, are going to be a major player in providing proteins for a plant-based protein alternative. And so if our major sources are all contaminated with this toxin that is resistant to heat, doesn't wash away very easily, is resistant to microwaving, it's a really hard catalyst to kill. One way to kill it is hydrogen peroxide, but I think we can all imagine what will happen if we douse our legumes in hydrogen peroxide. They probably won't taste very good. So we're developing biocatalysts to go in and very selectively destroy that toxin. And it's not the only way to deal with this toxin, I'll be clear, but we're developing catalysts to go in and destroy that toxin without affecting the broader functional profile of that food.
Well, wonderful. Let's see, there's so many questions to go with, so I'll just get into one. Maybe for Monjur. Dean Ornish mentioned in his session this morning that one of the ways you can transform people's diets to eating more plant-based foods is through a certain joy. And when you mentioned this terrible vegetable patty you had in 1991, that jived. And I just wondered, but at a big industrial food lab, how do you assess something like joy, or people really like it versus they'll eat it but they're not real happy about it? Is there a way to quantify that type of?
Yeah, we do quite a bit of consumer research. It basically start with our own developers, like when we basically start working on those products. So we'll have the team of the developers that basically kind of do the testing, sensory testings, and then we have a series of consumer testing that we do at different levels, starting from the central location testing, and then all the way to the in-home testing. So yes, it's like we constantly listen to our consumers because we do exist because of them. So right. So we would not be basically kind of doing any business if we don't listen to them. So yes, we basically kind of constantly get this feedback and then try to incorporate those as we formulate and refine the product before we basically bring to the consumers.
And is it like a numerical scale? Like, would you give this patty an 85, or you know?
There are several the tools that we have pretty strong the sensory team, and then we constantly improving our capabilities, sensory capabilities, trying to understand the sensory words that consumer will probably use then, because a lot of time there is kind of like we might be saying something, being like food scientists or the product developer, there's certain things that we take granted and kind of try to express them or communicate them, but the consumers might probably receive those or express those expression or the experience differently. So how do we understand those and trying to find the common language is like this is the key, so that we basically develop the great tasting product that consumers will love and enjoy. Just like you mentioned that you enjoy the Morningstar Farm products with your son every day. So it's definitely, if we ask you may not be probably describing all the jargons that we might probably use at our level, but definitely you basically would be able to communicate or describe the product that you are enjoying.
And Scott, how about you? Is in your work or with your colleagues, how do you assess like whether a patty or whatever it is just good versus great? How do we get into these more subjective experiences of food?
Yeah, so the way Givaudan would work is of course working with our customers like Kellogg's and Monjur to understand in the consumer testing panels what's the scores, how do we impact and rate the different flavors. But what's interesting now is we're looking at exploring artificial intelligence and predictive analytics to help us in this space, because consumers are notorious to say one thing and actually do another. And so if you can eliminate some of that by using predictive analytics, is there a way to get more accurate data? And so in our exploration of new startups, new technologies, we're constantly looking for things to help us in this way to become more effective, because consumer testing is one, it's not very reliable, and two, it's pretty expensive. And so by disrupting that model even, I think we can get better products to market faster.
And on that subject of using artificial intelligence to evaluate food, what do you, can you walk us a bit through how this works? Because my layperson's understanding is you're training the algorithms to look at thousands or perhaps millions of recipes and meals that people seem to like, and then it's able to make new connections. But how does a computer decide to add something?
Yeah, so
And be creative.
one of the interesting things with computational creativity is that it's very different than supervised learning. You don't want to train just on complete artifacts and consumer ratings, because the whole point is to do things that have never been done before. And so you really need to decompose your ratings into an understanding about the parts and their combining rules. So you want to understand individual ingredients, individual flavor compounds, and so on, and how they interact with one another. And that's what allows you to make predictions about things you've never created before, whether they'll be perceived as flavorful, whether they'll be perceived as novel. And one can draw on a lot of ideas from psychophysics as well as chemistry to try to make these kinds of predictions. So we often look at data from the basics of compounds and so on. One can start to then verify some of these predictions at the complete artifact level using consumer panels or sensory data. And another interesting aspect of this is that people, or a large fraction of people at least, very much like novel experiences. They're drawn to novelty. And so there's a lot of neuroscience of novelty and surprise perception that one can draw on. As an example, there's a quantity called Bayesian surprise, which is a quantity that measures how much your beliefs change by the introduction of a new product. So if you suggest something that's very different and unexpected, that'll draw people's attention. And that's something that can drive attention at minimum and behavior adoption, hopefully. So one can often mathematize these kinds of models and make these kind of predictive analytics out of these techniques. So that's roughly how one can go about doing these predictions about things that have never been done before, that you can only try to imagine and try to do that in a nice way.
And just one quick follow-up, and then I want to ask Justin another question. But with the with food, you're doing novel experiments with food that often has very long traditions and rigorous ones. So I'm thinking, for instance, of sushi. And my understanding is that a sushi apprentice has to spend a year or two of grueling training before he or she is allowed to even cut fish that's served. They can practice, but they can't serve. And so how do you deal with the kind of naive interloper problem, if you will, of, suddenly the AI thinks you should put barbecue sauce on the sushi, and then, people are aghast. Like, how do you deal with cultural resistance to these new ideas?
There's the adoption problem is certainly one of interest. So as I was mentioning, there's kind of pleasantness or liking as one dimension. There's novelty as another, but familiarity is actually the third kind of basic dimension in hedonic psychophysics. And so when one thinks about these things, one should also think about familiarity. One can do it at a person-specific level if one has data on someone's personal eating habits. One can do it at a regional cuisine level, and so on. And one of the approaches we've been taking is not doing kind of creativity from nothing, but in fact doing style transformation. So we'll take existing recipes and modify them a little bit so that they get closer to certain regional cuisine styles. Taking, say, sukiyaki, which is a traditional Japanese dish, and making it more French somehow by making a couple ingredient substitutions that also lead to the appropriate flavor profiles that will be perceived as good. So there's a variety of ways you can kind of create a narrative path. So you start with something that people already know and like, and you make small changes and you progress them towards a goal that you want to achieve.
Okay, thank you. Professor Siegel, we have a question from Slido for you. Similar to the biocatalyst to knock down aflatoxin, have you done any work on addressing pathogen bacteria toxins?
I've personally not done work on that. You can definitely imagine the same approaches being used. As long as you understand the molecular target of what you're trying to destroy in that food or pick out of that food, you can absolutely do it. Another example that we've done before is for celiac disease. There's very clear immunogenic epitopes within gluten that for people with celiac disease trigger the reaction. And we've gone through and we've engineered enzymes that ignore the overall food matrix and just go in and knock out that specific epitope within a person's stomach in real time. So that's actually, it was officially announced today that that's in clinical trials. It's been in clinical trials for a while. It was officially announced today that it's in clinical trials. And so you can imagine as soon as you know that molecular target, we have the tools of biology at hand. And the tools of biology, the beauty of them is they're specific as opposed to traditional chemical techniques, which are blunt force tools and very appropriate in many circumstances. But in a complex matrix, which describes most of the food world, where you want to have very precise molecular control, as soon as you understand that molecular control you want to have, you have the entire power of nature at your hand to start targeting those and modulating those properties.
And just a quick follow-up, I'm certainly totally agnostic on this very sometimes bitter GMO debate, but do you run into these types of concerns from people with creating
for the GMO debate? Yeah, absolutely. So I'll be very upfront. I'm not for or against GMOs. I think GMOs can be incredibly scary, both from a monoculture type agricultural risk perspective, from a societal risk, but incredibly powerful in enabling us to grow food where we never were able to grow food before, and start using non-arable land that now can be utilized, as well as building in nutritional properties. So there's a big debate on GMO there. The funny thing in the food system is that pretty much all of us eat all the non-GMO food out there. A good portion of it uses GMO processes in it. And for example, most of the cheese in the world, I guess I would assume everyone's familiar that rennet comes from horse hooves, right? Absolutely not. There are not enough horse hooves to make the cheese we need in the world. It is a recombinant engineering technology where you take the rennet enzyme, you throw it in a bacteria through genetic engineering techniques, you produce that protein, and then you use that protein to process that cheese, and it's a catalyst in the cheese processing aid. So there is no genetic material that actually ends up in the final product. The raw source material is not GMO. There's no genetic material from the GMO catalyst that ends up in that final product. So it actually is considered non-GMO, even though it's a highly GMO process. That's one of hundreds of examples in the food system. This is a huge multi-billion-dollar business for actually utilizing catalysts for a processing aid in the food system. Whether you like that or not, if we got rid of that, the food system would be in very serious trouble.
Yeah, and sort of on the subject of how do we retail food to consumers, and some of the shortcomings that are sometimes involved. I have a question that's getting a lot of upvotes about how plant-based meat typically has a lot of sodium and saturated fat. Is that a problem, or how do you weigh that against eating regular meat, or is there a way to do it with less salt and less fat and have it taste good? Yeah, Scott.
I'm happy to take that. So, as I mentioned, one of the technologies that Givaudan has been focused on is understanding how your body interprets salt. And salt is the cheapest flavor enhancer on the planet. It's used extensively and it has its purpose, but of course too much salt creates issues. And so once we understand how your body and sort of senses the salty perception, then we can find new solutions to replace salt. And so we have done lots of exploration in the space, and we have solutions that we can actually deploy to reduce the amount of salt that's used in processed food. And so, and it's clean label, it's still labeled as natural flavor, but yet you can reduce the level of salt. So we continue to explore these areas, we continue to find new solutions and commercialize those for the industry. So definitely it's on the top of our list, and it's not only salt, but it's also ways to reduce sugar and improve mouthfeel, umami, all those kinds of things, as I mentioned before, that were important in taste.
I'm going to actually jump in here as well, because I think this is a really important question, and I think I'm going to take it to the next level, because the question in essence is asking about the health advantages or disadvantages of plant-based proteins in the food system. And the unfortunate thing, and I think we've all experienced and we all understand, is that we know incredibly little about the health properties of any food. I'm stealing from my colleague a saying he often likes to use from Matt Lang. We know more, and this is absolutely true, we know more about every single drug in our medicine cabinet than any single food we eat. Right? Every single drug has gone through roughly 10 years of very rigorous double-blind clinical trials to understand safety, efficacy, and side effects. That has never been done for a single food in the world, ever. So if we need that to understand the health effects of a small molecule drug, which is a single component, how in the world are we going to understand complex matrices such as food? And we've seen that with eggs being good for you and bad for you, fats being good for you and bad for you, and it goes on and on and on. And actually, this is a particularly relevant, I saw this question popped up, and I'm glad we're talking about it, because just last week, or maybe it was 2 weeks ago now, and I'm pretty sure it was in the Journal of American JAMA, Journal of American Medical Association. There was a long longitudinal study, of a double-blind study, looking at sodium and salt intake and the health effects and outcomes from that. And this was tens of thousands of patients, and they found no correlation whatsoever between a high salt diet and a negative health impact. And they point out in that journal, the American Heart Association picked its number based on the best data it had at the time, decades ago. But it's probably totally irrelevant for the modern world we live in. So I think we really have to go to the question. We have to understand where our biases from and where we pick these numbers of healthy from, and understand that we just actually don't understand the health of food. And I'll finish up with that comes from funding, plain and simple. If you look at the NIH, there's roughly, $30 billion a year pumped into the diseases of old white men, luckily for me. Sorry. And the USDA budget to understand the health effects of, the USDA budget for public is $300 million, right? The Zuckerberg effort, and all applaud to private foundations and private individuals coming in saying they're going to help stuff, put $1 billion towards curing diseases. He could have tripled the USDA budget if he had put it towards understanding food, as opposed to making not even a dent in the NIH system. So I think it's really important for us to, if we start making health claims, to think back and realize that we really don't understand the health properties of the food we eat.
Yeah. And Monjur, do you want to talk about the issue of salt and fat?
Yeah, at Morningstar Farm, as I said before, we are a firm believer of delivering great tasting and nutritious food, and then we constantly looking into how we can improve our foods, and then so we are committed to kind of look into what our sodiums and the fat levels are, and then how do we basically find solutions to basically improve those, like Scott mentioned about. So we do have pretty rich kind of the partnerships, external partnerships with industry, academia, to find a toolbox that we can overcome. So to me, we cannot just look into just one particular the ingredient, salt or the fat. From the totality point of view, like how do we make this food taste good so that consumer can eat that one? Because what good it is, like if they don't eat the food, then you are basically kind of facing the challenge of the food waste. So we have to look into from all angles. And the one thing about like the taste, I was reading this book called this Molecular Gastronomy, where they talked about is like 80% of the beef, the flavor is due to aroma. So how do you basically kind of create the food that consumers will be delighted, not necessarily through this like just putting the salt. How do we create some food system that will basically create very unique flavor profile or the aroma, so that consumer can get excited and then feel good about eating this food. So yes, in a nutshell, so we are constantly looking for a very kind of broad the toolbox to make sure that our food are the nutritious and then tasty.
Mm-hmm. And sort of a somewhat related question that a lot of people are asking is this issue of describing the product. This is a sort of a retailing question as well, or marketing, describing it as meat, which the cattlemen's groups don't like when you have plant-based meat. They're like, that's not meat. And then certain vegetarians or people who don't like meat are like, wait, I don't like meat. Why are you calling this meat? How do you address that issue of calling it plant-based meat versus not?
So we don't usually get into whatever that the legislative probably the aspects of that, but from the Morningstar Farm point of view, our mantra is to basically get a plant-based the foods that consumers will eat. So not necessarily it needs to be called as the meat or alternative meat. So that's not our philosophy is. It's like our philosophy is like how do we bring a plant-based protein into their diet. So since our formation, the Morningstar Farm has been basically kind of the leader in bringing the plant-based protein into our everyday diet. So yeah, I think we'll probably leave that one up to the consumers, how they want to basically see that one, because you'll probably find a group of people, they want to probably see that one. I think we heard that one in the previous the panel. Like, they might probably call it in a different way, and then other consumers might be just fine with having a plant-based food. Like my daughter, who is 16, and she's not vegetarian, but probably a good portion of the week, she would prefer to have the plant-based or the vegetarian diet. So, but if I ask her, like, is she looking for a meat alternative? I'm pretty confident that she's not looking for that. She's just looking for the plant-based, the product that she could enjoy and then have it.
Well, and sort of as a follow-up that for you or any of our panelists, what do you think about what you might call the uncanny valley of meat? In other words, should we be trying to create a veggie burger or veggie hot dog or veggie bacon, or should we realize that a lot of really good vegan food is, its own thing? But also, how do you produce that at a large scale? And I know that this issue of what do you create speaks to your research too, Lev. What do you guys think? Should we be trying to create a better veggie patty, or should we be trying to create totally new kinds of plant-based protein?
Asking me,
or anyone who wants to pick it up.
Yeah, I'm all about creativity. I'm all about creating completely new products. I think that's perhaps the way to enter these markets. I think trying to recreate things, there are approaches for doing that. There's ways of hiding certain flavors and other flavors, what we call steganography, and other approaches. But I myself am a lifelong vegetarian, and I don't have a particular desire to recreate the flavor of meat. I just want something that is flavorful. And I think there's large segments of markets, especially in Asia, as was mentioned earlier today, where that is the case. So I think that is one way to go.
Yeah, and I'm the same way. It's let's just create great tasting food. Let's innovate, and we can let the marketeers worry about what to call it. But for me, it's we have the opportunity to create a new food system. So let's not try to imitate the past and what's known. Let's lean into the unknown, into the future. And together, I think we have, everyone in this room has the ability to be part of creating what that looks like. And for me, that is something new and not something that is new but called something old.
Yeah.
I guess everyone else has had input. I'll have a little input.
Yeah, please.
I'm definitely not a marketing expert, but I can't imagine anyone saying, well, okay, I can imagine some people. I can't imagine most people in the world thinking, wow, I want something because it came from an animal. Like, I think that's just a disconnect. So I think it's a massive waste of time for us to be fighting this meat battle. And we should just, as the panelists said, make phenomenal tasting food, new products, develop new food categories that people want. There's no reason to call it meat necessarily, because it's not meat. Spending time and money and effort thinking about and fighting against this, fighting that battle just seems like a total waste.
Yeah, and if I can add, if I can put on my historian of technology hat, if you look at the history of, for example, radio, it was initially called wireless telegraphy because people understood how telegraphy worked, and this was this new way of doing point-to-point communication. But the real kind of surge and explosion of radio happened when it was reimagined as not a point-to-point communication system, but a broadcast technology. And it took about 8 to 10 years before the name changed from wireless telegraphy to radio. And in fact, that change in naming actually had a very strong impact on adoption. So, and you can see these examples throughout the history of technology. And I think perhaps we're in the wireless telegraphy phase at the moment. We're calling things plant-based meat. But I think there's going to be a shift perhaps pretty soon where it is just a completely new thing where we don't need to understand new technologies in terms of old ones, but we can understand them on their own merits.
Maybe you can use AI to come up with a new name.
Yeah, for sure.
For Monjur, just on this these sort of tough problem of marketing large amounts of plant-based protein. I feel like a lot of the products that I get that are plant-based protein, or many that I buy from large companies, are frozen. And given what Professor Siegel was saying, exposing to us too about the world of bacteria and toxins, I assume part of this is for a food safety issue, but do you envision down the line us having more plant-based food that's fresh from companies like Kellogg's, or is it probably mostly going to be frozen for the near future?
No, as I said, ultimately, like you have to listen to our consumers and then provide them with the food that are convenient. So I agree, like it cannot be outside the freezer because we already see the jerky, there's a shelf-stable product. So the meat products are already in the form of shelf-stable products. So, and then at Morningstar Farm, we are constantly listening to our consumers and then see how far they want us to basically kind of expand. So right now, all Morningstar Farm products are in the freezer aisle, but in the future, there might be the expansion of what we do right now. So I think it will be probably very natural progression depending on the consumer needs or the consumer demands.
Okay. Well,
I could jump in there too, because this is an important question. And again, I'm going to go to moving beyond just that specific question, because I think it's beyond this specific panel, but just for the audience's understanding, right now in the US, there's a great EPA study a few years ago on this. Roughly 7% of the energy in the United States goes into the cold chain for food. That is a phenomenal amount of energy to keep our food fresh. The last innovation in alternative technologies to refrigeration, the alternatives are basically canning and drying. I think we can agree canning is probably not the best, and the last innovation in drying was well over 100 years ago. So this is an area that's ripe for innovation because we don't want to expand the energy footprint from a sustainability perspective of the cold chain. That has to change.
Can you add to that? Like in the earlier panel, we talked about, the panelists talked about the food service, like the business, like proliferation of the food service business, which would be great opportunity for these plant-based the foods. I think that might be another approach that we can take where you don't have to freeze or those products. So it's all depend on the point of use and how we use those products to basically offer the convenience that consumers are looking for.
Uh-huh.
Yeah, and just adding about the food supply chain, my research group recently has been looking at some problems using blockchain technologies to secure the food supply chain and be able to track back food contamination events. One can certainly start to think about settings where one has sensor data about the state of food as it goes through the food supply chain, and maybe actually use some of those data sources to come up with algorithms that can optimize the food supply chain to reduce energy footprint and so on.
Absolutely.
So I think there's growing uses of data and technologies in various senses that can help with these problems.
Okay. Well, we're coming just about to the end, but someone asked a good question on the online that might be a good summation question. What are some of the biggest obstacles, or what's one big obstacle you see to the widespread adoption of plant-based protein, based on your research program? Does anyone want to pick that up? You can also say I don't want to.
I can go. It's just like I think you basically probably started with that, like the versatility of the plant-based the protein. So right now, the supply chain, the developed supply chain is basically towards the soya, and how do we expand that one beyond soya? Like at Morningstar Farm, we constantly looking for that based on our consumer feedback that we have received. But when it comes to finding the next the plant protein, we need to understand from the totality. Like as I said earlier, like we cannot solve one problem and then create another problem. Like when it comes to the plant protein, most of the legumes or the crops, like you have only 20 up to 30% protein, there are a good portion of the carbohydrates present and then fat. So unless we find the supply chain solutions of those fractions, you really cannot fractionate those protein effectively and sustainable way. So collectively, everyone has to come to the table and find out, like if I am basically, like say for example, the pea protein, so we have to have a room for, or the home for that, the carbohydrate or the fiber that are present in the pea, so that you are not basically sitting on the diffuse the starch fraction that are basically generated. So collectively, we have to work towards finding the solutions, how to utilize of that total product. Because that's unique about the soy is like everything gets used, including the oil, because the oil seed, and then the protein used to be the byproduct. So, so that's the 2 cents regarding the challenges that we face right now.
Okay. Does anyone else want to?
Yeah, my quick piece on that is we have to leverage, for me anyway, is biotechnology. And I know our talk is plant-based, but for me, moving beyond that into clean meat, where you don't have plants that you have to grow and you have to only use 20% of it and find the use for the other 80%, and takes a long time to grow those materials. But for me, biotechnology at helping us even grow plants and grow meat is ultimately the solution we need to really invest in, and to me, that's the future.
Okay.
Yeah, for me, I think there's the product itself, which everyone here has been thinking about, but there's also the behavior adoption spreading through social networks. And so trying to bring those 2 ideas together, which marketers are good at, but I think there's also a lot of interesting food-specific questions about social networks that one can think about and try to address. So I think those 2 will together will help speed up the adoption.
Yeah, I think the panel's covered it pretty well. Doing great tasting products, a safe and sustainable supply chains, and putting it all together and getting it adopted. Just make great products. Don't fight an industry you don't need to fight.
Okay, well, thank you all to our panelists.